So why don't you do this also? Please note that x greater than or equal to 2 is an event. Y equal to 1 is also an event. You know what conditional probability is. So whatever we have done so far, you can use that to actually answer this question. Okay, fine. You don't need joint distributions to do this. Okay, fine. Okay, do it. Done.
2/3.
Okay. Okay, so let's do it and let's quickly check. Okay. Okay. So first coin 1 is tossed 3 times, and then depending on how many heads you get in the first toss, coin 2 will be tossed exactly that many times. Is that okay? So if you get 0 heads, then you'll not toss coin 2 at all. If you get 1 heads, then you'll toss coin 2 once. Okay, if you get 2 heads, then you'll toss coin 2 twice, and if you get 3 heads, then you toss coin 2 thrice. Is that fine? Okay, so just keep that in mind, and then we have to figure out this probability. So we can use the Bayes rule. Okay, of course you can draw the tree also and do the same thing, but I'll just straight away use the Bayes rule. Okay, so probability that x is greater than or equal to 2, given that y equals 1, is okay. So this is this is a formula for conditional probability. Right? Okay. Notice that this particular event, that x is greater than or equal to 2, y equal to 1, can also be written in this way. That numerator is actually probability that x is equal to 2, y equals 1, plus probability that x equals 3 and y equals 1. Right? Do you agree you can write the numerator in this way? Okay, because x greater than or equal to 2 is 2 possibilities. Okay, either x is 2 or x is 3. Okay, so and they are kind of disjoint. Okay, so if they are disjoint, you can actually write them as these two union of these two events. Okay, and because they are disjoint, these two are also disjoint. Okay, and therefore the probability of the union of these two events is actually uh, the sum of the probabilities of these events. Okay, so that's the numerator, and the denominator will just have one more term, because it's probability that y equals 1. So the denominator will be okay. Well, technically there is another term which is probability that x is 0 comma y equal to 1, but the probability of that is 0. The reason is because if you get a 0 heads, then you will not toss uh, the second coin at all. So if you don't toss it, you will not get any heads. So y will be actually 0 in that case for sure. So if you want, you can write it and then you can just put a 0 there. Otherwise there is no need. Okay, is that fine? Okay. Okay, so what is the numerator? Okay, now this is actually straightforward. Okay, so this term is actually probability that y equals 1 given that x equals 2 times the probability that x equals 2, right? Okay, the same thing. Okay, you condition on x, because you know how to find what is the probability that y equals 1 given that x is something, right? I mean, because then it's just a straightforward thing. So you just condition on x. Okay, so that's where this Bayes rule is playing a role. Okay, so you are now, instead of conditioning on y, you're conditioning on x, and you're writing this as probability that y equals 1 given that x equals to 2 times the probability that x equals to 2. Okay, now what is the probability that x equals to?
So 3 over 8.
3 over 8. Is that okay? The binomial 3 comma half random variable, and you just have to figure out what is the
Yeah.
probability that x equals to 2, and that's simplifying it. Okay, times what is the probability that y equals 1 given that x is 2. Now it is binomial 2 comma half random, right? So
Half.
what is the probability that it will take value 1? Okay, plus again do the same thing over here. What is the probability that x equals 2? Well, that's
1
1
over
by
8.
8. Okay, and what is the probability that y equals 1 given that x is 2? It is 2 by 8.
Hmm.
Okay, again, just write the first two terms exactly like this. Okay, what is the probability that x equals 1?
3 by 8.
And what is the probability that y equals 1 given that x equals 1?
Half.
Okay, very good. And now it's just straightforward, right? So I think we can cancel these 3 by 8s. Okay, so we'll be left with half plus 1 by 8 is, so 4 5 by 8 divided by half plus half, which is 1 plus 1 by 8, which is 9 by 8. Just check the calculation. Okay, so actually, none of the options is correct. So it is 10 by 18.